welcome all of you to this video of Maths Made Easy. Now, as I had told in my previous video that in this video I shall be starting with scale factor sums, okay, where this is the part of similarity where we talk about maps and models. This is also called a size transformation based on similarity. Now, what is it all about? Let us understand. Now, what is size transformation all about? Okay, this is a very simple concept where supposing you have a very small model of a ship. You all must have seen the model of a ship. This is a very small model of a ship which is actually so small that it can be kept on your table. Okay, so this is a small model of a ship, but then it has been made as a complete replica of an actual ship. Now, what they tell us is that the model of the ship and the actual ship, which is the big one, okay, they bear a constant ratio. Okay, now this ratio will be followed everywhere. Supposing they say the ratio is 1:300. This is what they call as K or the scale factor, nothing but a ratio. Now, as I told, it is K is equal to 1/300. Now, what it means simply is, supposing the model ship has a length of let's say 1 meters. Then the actual ship will have a length of 100 meters, 300 meters. Okay, now this is the meaning of the scale factor. If the model has a length of 5 meters, then the actual ship will have 1500 meters as the length of that particular part of the ship. Okay, maybe just this length they are talking about. Then in the actual ship also you have to take this length of the actual ship. So that is the meaning of scale factor. Now there is, as we do the sums, you will get an understanding of what is happening. But there is a very important thing that we need to understand. So as we proceed with the video, because without knowing that your sums will go wrong. Okay, and I cannot explain it without examples. So let us proceed with the sums, and as we proceed, the rest of the concept, I want to tell you another very important thing in this type of sums. Otherwise, without which, the knowledge of which your sums might go wrong. Okay, so let us proceed first with the first example. A triangle ABC has been enlarged by scale factor m is equal to 25. So you don't have to bother too much about this. Just in place of k, they have given a 2.m. That's it. To the triangle A dash B dash C dash means a triangle ABC, which was the original triangle, has been made into a triangle A dash B dash and C dash. Okay, it has been made into another triangle which is A dash, B dash and C dash. What is the scale factor? 2.5. Means, in very simple words, if the length of this is 1, the length of this will be 2.5. That's all. Okay, so here, and these two triangles are definitely similar. Now calculate the length of AB if A dash B dash is 6. Now let's calculate the length of AB. They told calculate the length of AB if A dash B dash is 6. Means this is 6. What is the value of this? I'll take this as x. Okay, and then this is what we do. Very simply, we just have to, now you have to use your common sense also in these sums. If this is the bigger one, so 2.5 will go for the bigger one. Means if I have written 2.5 here, I have to write 6 here in the denominator. And here I will write x, which is the length of AB. And here 2.5 is given, means it is 1:2.5. So x is how much? X is 6 by 2.5, which is 60 by 25. Okay, and that gives me here 5 and 12, which is 12 by 5, which is 2.4. So 2.4 centimeters is the length of AB. So I can write 2.4 here. Okay, so what is to be remembered is, for the bigger one the side was 6, so this bigger number I am going to give to the, if this is in the denominator, this also has to come in the denominator. 2.5 also has to be in the denominator. Now let's see the next part of the question, which says C dash A dash you have to find, means you have to find this where CA is equal to 4. So this is 4. Now they have given you just the opposite, they have given you the smaller side, the smaller triangle side, and they want you to find this. Let me take it as a y. Okay, and now we shall be finding that. So let's see. So here, first we are going to take, let's take ratio between. So I'll take y by 4. Now note one thing, I have taken y above. There's no such rule that you have to take y as the denominator. So y I have taken above and 4 below. Okay. Now the 2.5 is going to go above, because that is for the bigger 2.5. This, the bigger number goes there. Okay. So that is 2.5, okay, because when you find ratios, the bigger ratio will be there for, so this is actually 5 by 2. So if you want, you can make it 5 by 2 also, and here you have a 1. Okay, means the ratio between this to this is a 2.5 to 1, or you can even say it is a 5:2. So you can make it 1, or let's make it 5 by 2 also. Okay, no problem. 5 by 2 also makes it very easy. Now here 2. So y is equal to 10 centimeter. Means that the bigger triangle C dash A dash. Okay, so C dash A dash is a 10. So clearly note that this was 4, that became 10. So naturally there is an enlargement. Okay, now now this is our next question. On a map drawn to scale. Okay, so on a map drawn to scale, and what is the scale? The scale is 1 is to, this is 2,50,000. Okay, a triangular plot of land has AB, BC. Now we need to understand the question here. This is right angled at B. Okay, angle ABC is 90 degree, and AB is 3 centimeter and BC is 4. Now here we need to understand all these centimeter measurements are there on a map. This is on a map. Okay, now they are saying in the actual plot. Now you will note one thing, whenever we draw a map, then if I say the distance between Kolkata and Chennai, yes, and Chennai is few thousand kilometers. Okay, now but then in a map, what is the distance? In the map there is maybe just 4 centimeters, okay, or 5 centimeters depending on the size of the map. Now at the top right hand corner of the map, you will always find something written as a scale, and that is what this is. They give you the scale over there. Okay, now if the distance between this to this is a particular kilometers, okay, by that ratio it has been brought down and put in the map, and that same ratio will be followed. Now if you see between Chennai and Bangalore, if you want to see, okay, so the same ratio follows for any other distance between 2 points in the map. Okay, not just these 2 points. So that is the meaning of scale, that is any map will follow that ratio as the, because you can't be drawing a map with a few thousand kilometers on a map. So what you do, you reduce it to centimeters using a ratio, that's all. So here this is AB is 3, BC is 4, angle is 90 degree. Calculate the actual lengths of AB in kilometers, means in the actual plot, okay, and the area of the plot. So in the actual plot, now let me use this, and that too actual length they want in kilometers, though this is given in centimeters. This is something to be noted. So in the actual plot, here it is. So let me see, one thing is common sense. This is for the map and this side is for the actual plot, isn't it? So I will just take it like that. There is no learning up, memorizing any method. It is simply the bigger ratio, the bigger number in the ratio has to go for the actual plot. And here, this is how much? Here it is. Now, it is AB here, that is 3, okay, and we have to find the actual length of AB. and in the plot let the length of AB be x. The similar length of AB in the plot, let it be x kilometers. But as of now, we are doing the full sum in centimeters only. Remember, this does not have any units, it's a ratio, but this has a unit. So whatever value of x I will get it in centimeters. Okay, so now here it is, x is how much? X is 75 by cross multiplication. Okay, so x is 75 and 4 zeros. So if x is 75 and 4 zeros, then this is, remember, we have got AB of side of the plot in centimeters, but we need to convert it into kilometers. So we will write here how much? We will first, centimeter to meter is a 100 and meters to kilometers is 1000. So we are actually dividing by 5 zeros. That makes it 7.5 kilometer. Okay, so that is the first part of the sum, that is we got AB in kilometers. Let me find BC also. Now we'll take 4 because that is for the map, 1 by 2, 5 and 4 zeros, and here is Y. 1 into, now this is 4 into 25 makes 100 and then 4 zeros. But this is Y. Y is this many centimeters because this was in centimeter, whole sum has come in centimeters. Y value has come in centimeters. Now we'll convert it to kilometers. Okay, how many zeros? 5 zeros, cancel them, 10 kilometers. So the side BC is a 10 kilometer. Now that is not the end of the story. Area of the plot, actual plot in square kilometer we need to find. Now what will we do? Full sum. So area of the plot. Okay, how much is the area of the plot now? So area of the plot will be this side. Now this is BC is a 10, right? And this is a 7.5. So we'll go by the triangle formula, half into 10 into half into base into height, which is 75 by 2, which is 37.5 square kilometer. Okay, so that is my answer. So here what was very important, every sum will try to trick you in a different way. So here what was important, very important, was this centimeter to kilometer conversion. Rest was a simple question. Okay, so be very careful about the units. Let us see another question. Now I really like this question. One question does many things. Model of an aeroplane is made to scale they have given. Means there's a big aeroplane, they are making a small model of it in this ratio. Means actual aeroplane is 400 times of the model. Calculate the length and centimeter of the model. Okay, calculate the length and centimeter of the model. Now what is important here is to note this. Okay, don't neglect this length and centimeter of the model if the length of the actual aeroplane is 40 meters. Mismatch in units. Okay, so we know the scale. We'll just put the scale. Okay, and here length and centimeter of the model. Let us take the length and centimeter of the model as an x. So I have put it above near this with the smaller ratio. Okay, it has to correspond to the smaller ratio, and below that it is length of the aeroplane is a 40. Now 40 meters. 40 meters. So we can do one thing, we can change this to centimeter now only, or we can do the full sum, get our answer in meters and then change it to centimeter. So we'll just do the full sum now, cancel it. Okay, 4, 10. So this x is 1/10 of a meter because this was in meters. Now we have to convert that to centimeter, that is into 100. That makes it as 10 centimeter is our answer. Okay, so the first answer is 10 centimeter. Let's come to the second answer. Now this is the second part of the question, length in meters of the aeroplane. They are asking for the bigger value now of the aeroplane, the length of the aeroplane. Okay, so there's a different case but ratio is same. Okay, here is one case, here is another case, ratio remains same. Length of the model is 16. So if the model is 16, okay, I'll first write 1 by 400 because ratio is same, and here I will put the model's value here 16. Okay, and here is y is the length of the aeroplane. So y is how much? 400 into 16, but then this is coming in centimeters. I have to get my answer in meters, so here I will divide by 100. Okay, so I get a 64 what? I get a 64 meters is my answer. The sum that I am going to take up now is, I consider, one of the most important questions in this chapter, because one question and it does, three jobs altogether. And as I said in the beginning, there is something very important at the end of the video. Okay, so please watch till the end, because this is going to give you a lot of more marks questions. These are the 4 markers, this type of questions that I am going to do now. Now this is our next question. As I said, very important question. This is the model of a ship is made to this scale, 1:300. Means the model is 1, then the ship is 300 times of that. The length of the model is 2 meters. Okay, now the ship can have a length, it can have an area, it can also have a volume. Okay, area of any particular part. Here they are talking about the area of the deck of the ship. Okay, so here length of the model of the ship, it has a length of 2 meters. So 2, okay, find the length of the ship. So if you can take x as the length of the ship, then that is a plane 1/300. Okay, so the ship is 600. So the actual ship has a length of 600 meters. Okay, now we'll come to the second part of the question. This was our first part. Come to the second part of the question, which says area of the deck of the actual ship has been given to you here. Calculate the area of the deck of the model. So the model also has a deck, but then it's going to be very small as compared to the ship. So how big will it be with this ratio? Okay, so let me take that area of the deck of the model as a y, and area of the deck of the actual ship 18 and 4 zeros. Okay, 300 comes with the ship, corresponds to the ship, and 1 here. Okay, but then if you do this, your sum goes wrong, because whenever we are talking about area, this time we are not talking about, till now I kept doing length. Here we have started talking about area. So here what you have to do is, you have to square the scale factor. Okay, because the values here, area, it has a length, it has a breadth, both of them have the scale factor. Okay, both of them will be reduced or increased using the scale factor. That is why whenever we are using area, remember to square the scale factor. Now I have squared it. Okay, if you don't do that, your sum goes wrong. So here 3, this is 6, and 3, this is 2. So y, that is the area of the deck, comes to a 2 meter square. Area of deck, actual deck, is a 2. Area of the deck, that is area of the deck of the model, comes to a 2 meter square. Here length of ship, that comes to 600 meters. Okay, now let us come to the third part of the question. What is it asking? The volume of the model ship is 6.5 meter cube. Calculate the volume of the actual ship. Okay, now they want the actual volume of the ship, so don't be scared, it's going to be a very big number. So now here this is model ship's value. Okay, everything is in meter cube, and let me take Z as the volume of the actual ship, and then here you see what happens. This is why I told, watch till the end of the video. If it is a volume, you have to cube the ratio, the scale factor. Okay, and now we are going to find the value of this Z. Okay, so Z comes to 6.5 into 27 into 10 to the power 6, right? And 6.5 into 27 gives me 175.5 into 10 to the power 6. Okay, so it is that many meter cube. Okay, it has to be huge because after all it is a ship. So this is the full sum. Why I picked up this sum? Because here it talked about length, then it talked about area, and then it talked about volume. So this is the volume of the actual. Okay, so I think this video takes every important aspect of this particular size transformation, maps and models, this part of similarity completely. With the help of these few sums, you can do practice of all the sums in your exercise of this particular type. Okay, the next video that I am going to take up is similarity, in which we are going to talk about the area ratio between the areas of two similar triangles. Along with it, that how do the sides of the triangle have a relation. Okay, so I am going to talk about that part of the chapter. If you have liked the video, please don't forget to like, share and subscribe. Also, you can put down in the comment section what is your doubt area and I can make videos on that. Thanks for watching the video. Bye then.